Hello everyone, and this is physics. In this video, I'd like to have a short conversation regarding simple addition of vectors. Now, vectors are generally depicted as arrows. I'm just going to draw an arrow here. Consider this to be a vector. And in my case right now, I'm going to use this as a force vector. Force vector. Which means I'm going to use the unit of a Newton. In the metric system, forces are newtons. I could use an acceleration vector, and the units then would be meters per second squared. I could use a velocity vector, in the case the unit then would be in meters per second or kilometers per hour. But I'm going to stay with force vectors. And this vector here has two ends to it. And this end here we're going to call the tail. And that one the tip. And vectors have both magnitude and direction. Magnitude. And that's just a fancy word for the strength of the vector, or the size of the force that I'm applying, or how fast a particular car is moving in speed-wise. It's just a number that determining the size of the vector. In our case, I'm going to use forces. So I'm going to consider this, for the sake of easy numbers, 10 newtons. There's a 10 Newton force going in that direction. And vectors also have direction. I just said directions. They also have a direction. Now I can't just simply say to the right. Well, I could say to the right, but that making it a little hard for the mathematics. So we need a coordinate system. So there's different kinds of coordinate systems that one can use. And one is we'll use the compass. Compass can be used as a coordinate system, in which case this up will be north and down will be south, going to the right will be east, and going to the left would be west. And I know this is the west and the east always spells the word we. And if I rearrange these letters, I will get the word news. But I could also use the Cartesian plane. This is the XY plane. Cartesian plane. Similar to this, we have an X and a Y axes. Here's the X. Here's the Y. So going that way, we're going to call that plus. Going this way, we're going to call that minus. Minus X direction. Going up, it'd be plus. And down will be minus. So this is our coordinate system. I'm going to use this coordinate system for our demonstration. So taking this vector now with magnitude and direction, it has a magnitude of 10 newtons going in along the positive x-axis, going that way. Let's do an example. And for the sake of completeness, if I wanted to use this one, this vector right here is traveling east. I could make east positive and west negative, but that's for another video. We're going to stay with this one. So consider these three vectors. I'll do the same as I did earlier. 10 newtons. And I'm going to put on another vector. I'm going to use a different color. So if that's 10 newtons, I want to keep the same scale. When we draw these vectors, I like to try and keep it to a scale. So if that's 10, and I want to make another one going in that direction, say 15. I'll make it 5. I'm going to go 5 that way. I'm going to keep the numbers simple. So 5 will be half of this. So I'm going to put it over here, about that long. So there's another vector, 5 newtons going to the right. And let's put on another vector. On top of that, I'm going to use a different color, going this way to my left. So if that's 10, I want to go 15. No, that'll cancel it out. So let's go 8 to the left. Nope, 10, 15. Let's do a simple number like 20. We'll go with 20. Starting here then, if that's 10, there's 10. I want another 10 over here just to keep the scale. 20 newtons going this way. So I have three vectors. And the task of this video is to sum up these three vectors. All three of them are coplanar, they're on the same plane, and they're all completely horizontal on the plane going left or right. I'm going to use the Cartesian plane for direction. Okay. So any vectors going to my right, I'm going to have positive value to them along the x-axis, will be positive. Any vectors going to my left will be negative. And then there's the y-axis, but none of these here are going in the y-axis, so I can ignore that. Having said that, now I can give these numbers here, these magnitudes of a sign. Going that way, this will be plus 10 newtons. According to my coordinate system, plus 10 newtons means it's going to my right. This one here is also plus 5 newtons. And this one is minus 20 newtons. That minus sign indicates that it's going to the left, going towards the negative x-axis this way. And now the question is, add up these three vectors. Add the three vectors. One way to add these vectors is pictorially, which means it's a sketch. We can do this pictorially, which means I'm gonna make a sketch, a drawing of the vectors. And we can do that because a property of vectors is they can be picked up and moved. I can take this vector and I could move it anywhere on this page as long as I maintain the magnitude and I maintain the direction. And same with this one, I can pick that up and move it anywhere on this page, and same with this one. That is a property of vectors. So to add up these three vectors using a sketch or pictorially, we're going to put them tip to tail. Tip to tail. Going to redraw them tip to tail, add them up. So earlier I said here's the tail, and that one's the tip. So let's pick up this vector, this 10 Newton vector. I'm going to pick it up from here, and I'm going to put it down here. I can move it anywhere as long as it's on this plane, going in the same direction, same magnitude. So, okay, I'm going to have to use two hands for this one. It's about that big. I want to keep the same scale, so I'm going to move it over here. I'll move it over here. Going that way, 10 newtons. Then I'm going to pick up this vector. Let's see if I can get that color again. Pick that up, and I'm going to put it here, tip to tail. Here's the tail, there's the tip, here's the tip of this vector. So I'm going to connect up the tip and the tail together. And this has a value of 5 newtons. And right here is the connection of tip to tail. And then this vector, it's going in the opposite direction. And I'm going to also add this to these two vectors, tip to tail. I'm going to go at the very end of these two vectors here. And put the tail to the tip. And I should go over top of this one going backwards. But then you won't be able to really see it. So I'm going to connect it here. So here's my tip to tail connection. Tip to tail connection here. And the vector is going to my left. A value of 20 newtons. Something like this. Go about that big. In the opposite direction. So this one is plus 10, plus 5, minus 20 newtons. And they're all connected tip to tail. The summation of these three vectors is known as the resultant. I'll squeeze that word in here somewhere. The summation of these three is known as the resultant. Resultant vector. And the resultant vector, pictorially looking at this, you start here at the beginning of all the vectors. When I started adding everything up, I started here. And I'm going to draw a vector from the tail of this one to the tip, the tip of the very last vector, which is here. So the resultant vector is actually from here. See if I got a different marker I can use. To here, where this one ends. This is the resultant vector right here. the resultant vector. That's our answer. The summation of these, pictorially speaking, that's our answer. So it's going to be that much magnitude going to the left. We have to give this a number. Well, we have some numbers, so we can do this algebraically now. So going on up, the sum of the vectors algebraically, this sigma here represents the sum of the vectors, which means I'm going to add all these up here algebraically now, and that's where these signs come in handy, is equal to plus 10 newtons plus, that's what this means, sum of, so I'm going to add everything up, plus 5 plus a minus 20. Now I'm being very specific here, showing the pluses, the plus, because that's what this symbol means. So doing some algebra to this, the sum of the vectors then is equal to plus 10. We don't generally put in a plus sign when it's a positive 10 in algebra, so that's plus 10. Plus times a plus is a plus, plus 5. A plus times a minus is minus 20. And the units for everything here is in newtons. This is newtons, that's newtons, newtons. So we could add everything up. That comes to 10 plus 5 is 15, minus 20, and it's going to be in newtons, is equal to minus 5 newtons. 15 minus 20 is minus 5 newtons. So the summation of these three vectors results in a resultant vector. This is the resultant vector. The resultant vector, running out of ink, minus 5 newtons. And if we look at our picture, that negative sign, because according to the coordinate system that I chose, the negative signs means the vector is going to my left. Look at the picture, this matches that. So now I have an actual value for this pictorial picture right here of minus 5 newtons. And that negative sign means it's going to my left. So this is the summation of three vectors, all horizontal. Completely horizontal, completely horizontal. It's easy. Just to add the vectors, just place them tip to tail pictorially and choose a coordinate system, and generally it's going to be the XY Cartesian plane. But it could be the compass. Using this system, then give all the numbers a plus or minus sign, and such that the algebra then will work. When you do the summation of them, then the algebra works because you've given each one the proper sign. So let's do one. This is all horizontal. Quickly, consider three vectors which are now vertical. All three vectors are vertical. Similar idea, I'll just go through this one a little quicker. Going to have three vectors. That one going straight up, starting here, and we'll give this 6 newtons going up. Here's another vector, I'll just drop it over here. Going up that way, give it one extra, and then that one 7 newtons going up, and another one going down this way. We'll call this one 5 newtons. Three vectors, all of them completely horizontal, vertical I should say. All of them on the same plane. Add up all these three vectors. We can do that pictorially by putting them tip to tails, and we can move these vectors. So I'll just move them over here. Take that 6 newton and put it over here. And adding this the tip to tail, I'm going to place this one to that 6 newton, pick it up and move it over here. Tip to tail connection. Here's the tip to tail connection. And this has a value of 7 newtons, both of them going up. And this one is 5 newtons coming down. It'll be tip to tail connecting here, bringing it down 5 newtons. Superimposed on here, but it's difficult to show when it's superimposed, so I'll just use a different color next to it. Try and keep the proper scale. So this is 5, that's 7, so it can't be greater than the 7, so this is 5 newtons going down. The resultant vector then becomes where you started, is the vector where you started to where all the summation of these 3 ended. So the resultant vector would be, what do we have here in the way of colors? Here's the black one. Starting here and bringing it to the tip of the last vector. This one right here, that is the resultant vector, the summation of those 3. Now we just need to know what it is. So if we use our Cartesian plane again, here's the y-axis, there's the x-axis. Up we're going to call positive, down is minus. Therefore this number here is plus 6, plus 7, and going down is minus. This will be minus 5. So algebraically then, summation of these vertical vectors is equal to plus 6 plus a plus 7 plus a minus 5. All of them in newtons. So doing the algebra, we have 6 newtons plus 7 newtons plus minus minus a minus, plus times a minus, minus 5. Everything here is in newtons. Yeah. 6 plus 7 is 13, minus 5, and that brings us to plus 8. And that is the resultant vector. The answer to the summation of these 3 vectors, all vertical, all on the same plane, all going in a straight line. Just going to check my math a little bit here and make sure it's 13 plus 8. And if I look at this pictorially, this is my resultant vector. This tells me it's going up a value of 8 newtons. And this vector here, you can see starts here, goes up. And the value of that resultant vector mathematically is 8 newtons. Plus 8 newtons. So this is the addition of simple vectors, completely horizontal vectors, and completely vertical vectors. They're easy to add up. And this is physics.